I guess the question and answer is how we might have a problem with the Q&A afterwards, I guess.
Yeah, that's right.
Okay, if everyone could take their seats, we'll begin the next presentation. The next presentation is entitled Suspicious Order Monitoring and the Power of Data, Sink or Swim. Our two presenters, one virtually will be Eric Brantley, SOM Engagement Manager at IQVIA. And we also have Theo Antoniou, the Chief Technology Officer for MD Scripts. As a reminder, the full biographies are on our website with the presentations. I'd also like to take this opportunity to thank Theo and his team of Joe, Travis, and also I'd like to thank their president, Gary, who is in attendance, for, in addition to being one of our valued sponsors, they also helped us in getting our website update up and going. We had been having delays with the contractor for about a year, and Theo learned of our issue, and what seemed a matter of hours, we were up and running and had the website that we were wanting active. So I want to thank Theo and his team for that. Without any further ado, Theo.
Thank you. Hi, I'm Theo, and I work at MD Scripts. We're a software engineering firm, and I wanted to talk a little bit about pharmacy data because I know everybody's involved with a lot of pharmacy data, and I kind of wanted to go through a couple of different formats and how it's moved around and transports but before I do that, I didn't want to just throw out all of these protocols and formats and just make it, you get nothing out of it. And I remember when I was in college, we were electrical engineers, and we had to take one chemistry class to graduate, and we all dreaded it. And when we got to that chemistry class, the professor told us, you only have to remember one thing from this class. You can forget everything else, but only this one thing is you have to remember. And so now he told us the one thing you have to remember is that entropy always expands in the universe, right? And we had no idea what that meant. But he said, that's the only thing you have to know. And today, I can't remember a thing from that class, but it's the one thing I do remember from that class. So we're going to do the same thing here. And point. The green button, right? There we go. So we're going to give you three things to remember. And you can pick your favorite one. The entropy always expanding is the second law of thermodynamics. And there's three of them. I'm going to have three here, and you can just pick your favorite one. So here we go. So the first thing I'd like to talk about is EDI formats. So EDI formats are just bytes that go into files. Very common one is HL7. HL7 is a EDI format that's used for mostly around hospitals. So they'll pass all the data around between hospital systems, and that's what they primarily use to communicate between pharmacy systems and EMRs. The next set of standards are the ANSI standards, and this is by the American National Standards Institute. These standards exist outside of pharmacy as well. So they have these definitions for anything that you're shipping, like containers and so forth. Very common one that's used in pharmacy is the 856. This is used for track and trace, for the traceability of medications between the manufacturers, the wholesalers, and the pharmacies. And then there's a couple other standards. There's the product transfer, product activity. These are primarily used between manufacturers and their wholesalers to kind of see, what's going on with their products. Okay. So this body controls these standards. Over time, they change. So one of the biggest complaints, just like other standards, is well, you're using version this of this standard, and so the issues like that. So ASAP is the standard that most of folks in this room know about. This is a group, it's American Society for Automation in Pharmacy. And so they have a EDI format. It's different from the ANSI and the HL7, but they specify what the files look like for passing around the data. Now, this ASAP format has PHI in it, and that's a very key thing. Most of these other types of standards don't have PHI in them. And then there's other standards like the ARCO standard. They have their own custom EDI format. They say if you want to report the Schedule 2s that you're buying, this is the format that you have to put it in, and they'll specify that. So this is what one of these ANSI files looks like. The first part of every line is some kind of identifier, and it's followed by these bytes and bits that mean various things. Normally the position in the line is what tells you what the value is. Everybody can choose their own end of line terminator. This one here has the tilde sign as a separator. And then the third character from the right tells you what's the field separator. So this one is using asterisks. So all the folks that are passing around EDI files, this is what they look like. There's nothing really complicated about them. They're just these files with this data. You have to have the standard to know what's the fourth field in the TDI line, right? This is what ASAP looks like. So just different headers. They use PH at the first line instead of ISA. And then all the traditional headers that you guys probably heard of, the FA header for pharmacy and PAT, DSP, and so forth. Normally, they just add stuff to the ends of the lines to make them backwards compatible. And sometimes they'll add new segments, but the segments are pretty much fixed. One thing that's difficult about these files is that they're looping. And what that means is that I can start off and say pharmacy, and I can go patient, dispense, patient, dispense, patient, dispense, and then list a whole bunch of patients still under that initial pharmacy. Now, if I want to, I can say patient and then go pharmacy, 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 pharmacy. So the order of the looping is not really specified, and that adds some complexity to the processing of these files, let alone just that anybody, you can see here in the ASAP format, the line separator is a backslash. So these little things, not hard to overcome, but just more time, more money because of the varying standards. You can see here, for example, in the patient, if you know PAT 07 is the phone number and so forth, nothing really magical about these files. These files were used back in the 80s when people had modems. So they're very, very effective because you can take 800 bytes, fire up your 2400 baud modem, right? And send it over and it works. But today, this level of encryption, is really not needed. And it's very hard to open up one of these files, look at it and say, oh, I see what the problem is, right? But the bigger problem with these files, and this is the first thing I want you to remember, is that very seldom are these files encrypted at rest. So our company is forced by high trust certification to not have any files on our desks that contain PHI that are not encrypted. So somebody breaks into one of our servers, they just can't go to the directory and see all the patients. And from what I've seen in my experiences is that majority of these files that are being passed around, the ASAP files are not encrypted. And so that's the first thing I want you folks to remember is to always encrypt the data at rest. The next formatting I want to talk about is XML. So XML is just like the EDI files, except instead of using stars and lines, they use like these little tags. And it looks like HTML, But instead of these just lines, what you do is you say open tag like head, and then some data, and then close tag. And an example of XML formats is the NCPDP script standard. This is the standard that's used for e-prescribing between EMRs and SureScripts and pharmacies. So what we do is we encode all of this data into these XML structures, and that's how we pass it around in between the servers. Another example of XML is the NASCSA standard. This is the track and trace standard. This is another XML standard. And here's an example XML file. And so you can see they always start off with an XML identifier, what the encoding type is. And they just have things like, here's a started header, here's the end of the header, and then here's a new RX, and here's an old RX. So this is an example of what you would send to SureScripts if you're e-prescribing between an EMR, and then the pharmacy software receives the other side of this. Typically, these files are not stored on disks. The XML is typically used as, I'll send you a message and you'll send me back a response. So typically these files are not encrypted and they're usually used in real-time communication back and forth. Another standard is CSV, just comma separated values. These is a very low level type of file. And so you can typically open this up with your Excel spreadsheet or whatever spreadsheet program you use. And what's nice about this is that people can just open these up and look at the columns. The bad part is those programs tend to strip off the leading zeros. And if the number is too big, they'll convert the number into something that has an E and a plus in it. And then that shows up in the data downstream and you wonder why they showed up in your data. So PDP collection agencies, a lot of times when they report back data to folks, they'll put it in a CSV file. Rebate aggregators, typically those folks, when they want your rebate data, they'll want it in a CSV format. So you format up a CSV file. And of course, a lot of data warehouses that deal with pharmacy data, CSV file is usually their preferred method of data transfer. And CSV file, very simple, just field, comma, field, comma, field. And then if there's something complicated like a comma in your data, then you typically have to put double quotes around it. So this is very, very common. Oh boy, byte encoded. So in this format, some folks have gotten together and what they do is they say, we'll make up a series of bytes. And this is how you communicate between two entities. So the NCPDP used to have the standard 5.1 for claim adjudication, and now they're on the standard D.0. And what they do is they say, okay, the first 6 bytes are the bin, and then the number D0 shows up, and then the next 4 bytes are the PCN and so forth, right? So very, very complicated encoding. Now, it's very small and optimized, but this encoding is very, very difficult. And it very often is done wrong. And this is how pharmacy programs adjudicate claims through switches to the PBMs and back. So then this is, I call this a byte encoded format because when you look at that byte string, you really can't tell what it is unless you actually know, okay, after the field separator, C4 is the date of birth. So I know to go find that in the data. So fun fact, the reason why this is called D0 is because the standards group used to be on 5.1. And so they use a byte for this, and it's the byte that's in red on the first line. And then they got to version 14, and they're like, well, we can't fit 14.0 in 1 byte, but it's a byte. So A, when you hexadecimal encode things, it goes A is 10, B is 12, 13, all the way up to F, right? So the D.0 is for version 14 of the NCPDP claim standard. And then the servers respond back with an answer. Very, very compact. So places like Relay Health and ERX Network that process these claims. Their data channel is very, very effective at passing these through. Most of the time, 1 to 4 claims in these, and there's usually 800 to 1,000 bytes, very, very small encrypting. Oh boy, so in the work comp space, of course, they don't take anything electronically. We have to put it up here because this is a form of data transfer. But if you go to Office Depot, you can buy one of these red forms. They're red because some people scan them. And you put in all your PHI, all your patient information, put a couple hundred of them, put them in the mail and hope they get there. So, and then the collectors, they sit on them for a bunch of time. It's a slow to pay scheme primarily because they could set up a PBM in a heartbeat if they wanted to. But this is a HCFA 1500, and we deal with these every day. Very, very common in pharmacy, even today. One of the issues with the data standards is that there's competing standards, right? So the group called the NCPDP, which is followed by almost all of pharmacy for their standards definitions and their field definitions, they have data dictionaries, and they have all of these values already defined. So if you're looking for a definition for RX origin, it's in the NCPDP data dictionary, and it's field 419 DJ, and they have it defined. Now, the ASAP group, whenever they come up with their own fields, instead of just using the same definitions, they come up with their own numbering. And so there's about a dozen or so fields in the ASAP standard that don't align with the NCPDP standard, and it just makes data sharing more difficult because you have to convert back and forth. Not a big problem, but on the RX origin, they were really, really close. They were lined up until telephone, and then they stuck in telephone emergency in there instead of electronic. And so they had to go to 5 for electronic. That one was close, but you can see the differences in gender, the NDC identifier, about 10 or 12 of these are different. But it would be great if all of these fields had one definition and everybody agreed on them. So transport is how we pass these data files around, because whether you have EDI or XML or HCFA 1500s, transport means how do I get the data from point A to point B? So the first one is USPS. This has to be on here just because of HCFAs. 10 years ago, we used to mail CD to cures, all those kinds of things. Fax is on here because even today with SureScripts, their fallback method, if the SureScripts number goes down, is to fax. And so there's a lot of pharmacy data still being transported around via fax. TCP/IP is the low-level internet protocol. This is how, if you want to send a claim, to a PBM, it's typically done through TCP/IP. So that heavy-duty byte-encoded scheme that I mentioned before, normally what you do is you open up a socket to a server and you encode these bytes and send them over, and then they send you back some bytes. That's done over low-level TCP/IP. FTP, I think is well known in here. This is a file transfer protocol. I have a username, a password, and a URL, and I can communicate with the server. It lets me put files there and get files back. So normally you need to know about 4 or 5 things to do this effectively, like username, password, port, URL, and those kinds of things, and maybe the folder to put them in. But usually everybody has to have their own username and credentials and so forth. So Walmart had too many vendors, didn't want to support all these different FTP folders, so they came up with AS2. And AS2 is glorified FTP. It's like a file transfer, but it makes the setup much easier. I just give you my AS2 address and you give me yours. And if everything works well, we can interchange files very easily and very securely. HTTP is, you've probably seen it in your web browser. It's a protocol for communicating on the web. It's the standard for that. Most web services are on HTTP. When you send an email, the standard that's used for that is called SMTP. And so it's a send mail transfer protocol. And this is here because a lot of things we do today, the only way the other side gets them is through email. So if you place an order, a vendor will go to us, sorry, the only way we can get that order from you is via email. So that's an SMTP protocol. We have email listeners on accounts. They just sit there, and when somebody sends us a message to this special email address like sales@mycompany.com, it'll take the enclosure in that email and treat it as an order, for example. And then there's blockchain and distributed. You heard a little bit in the last presentation about Bitcoin. This is a scheme where nobody owns the data. It's all passed around. There's trust mechanisms, all these different things to support a distributed, decentralized and distributed network. And I don't know what, you can spend a whole hour talking about just this part and what people are trying to use this in pharmacy, but we'll just save that for a different day. The second thing I wanted you guys to remember after this presentation is real-time transports only. So we know all the problems that are happening today because you get like a daily file and then the data comes back the next day and there's errors, and then I got to go back and fix those. And then the patients in that time can go to 10 pharmacies, all of those issues that are related to non-real-time communication. So FTP, the mechanism by which most ASAP files are transported, is a non-real-time protocol, which means you don't just send a file and get an answer back. Claim adjudication, the way pharmacies get their money from PBMs, that's a real-time standard. You send in the claim information and tell you right away whether or not it's too soon for that medication, whether there's a DUR, how much money you're going to get paid. And that happens in real time in just one couple seconds. So of all these transports, only 2 of them are real time. And that's HTTP and TCP/IP. TCP/IP is what claim adjudication is done with, and HTTP is what all the web services are. All the rest of these are non-real time. So that means you can't get an answer right now. You have to come back and get it some other time. So please, real-time transports only going forward, okay? That's the year. So I'm gonna put some entities up here and I'm gonna draw all the lines between them so you can kind of see what we're talking about. So the hospitals, prescribers, pharmacies, wholesalers, manufacturers. So those are the main entities that I've up here. SureScripts, okay, they're the folks that take in the e-prescriptions. They take them in from pharmacies and EMRs. The switches are the people who route claims to the various PBMs. Work comp adjusters are people that get HCFA forms. P&P collection agencies are places like Bamboo Health and so forth. Rebate aggregators are folks that collect data and then submit it to manufacturers to get money back. And then data warehouses typically are there to collect data because wholesalers and manufacturers don't have an effective means to communicate just in between themselves. And then track and trace is the network of folks who are involved in pedigree and the traceability of medications. On the side there, I have the PBMs, which talk to the switches, and then the state P&P and controlled substance boards that talk to the P&P collection agencies. So the first arrow I have down there is an EDI HL7 format between hospitals and prescribers. So that is a EDI format. It's got all these little byte encoded things. It's non-real time because they just pass files around. Sometimes the systems will respond back with an acknowledgement file, but it's still not real time. The prescriber to SureScripts interface, that's encoded in XML using the NCPDP script standard 2017. And when a prescriber sends a script to SureScripts, they get an answer back right away that the script was accepted. SureScripts then takes that and sends it to pharmacies. That's another real-time interface. There's no file sharing, no nothing. Those applications are to communicate directly with SureScripts and get back answers right away. Now, when the pharmacy says, well, I want to adjudicate this claim, that's also real time. And we talked about that a little bit, about how that's just this hideous byte encoded format that goes through the switches to the PBMs and back to tell you how much money you're going to collect. The work comp claims from pharmacies that go to work comp adjusters, those are those red forms, and they're usually sent by mail. And if they don't get paid, then they send them by registered mail, right? there's our area here. So this is EDI format, ASAP 4.2, going from the pharmacies to the collection agencies. So non-real-time EDI format with all the characters and stars encoded in the files. And then the P&P collection agencies send it off to the state P&P or the folks that need to see that data. Pharmacies will submit data to rebate aggregators. This is only done a little bit. The majority of rebates are paid to PBMs. So the PBMs are the ones, when they submit their rebate data, traditionally go straight to the manufacturers. But when pharmacies are involved in getting monies for rebates, there's a path between the pharmacies and the rebate aggregators in the form of a CVS file, non-real time. They just give them a file a month, usually, or a file a week that says, here's all our rebatable dispenses. In between the manufacturers, wholesalers, and pharmacies, there's all these EDI formats, primarily for track and trace, ordering, purchase orders, those kinds of things. No patient information in these. It's just, this is how many you ordered, and then, here's the NDC numbers and so forth. And non-real time, just file transfer back and forth. A lot of times the manufacturers and wholesalers and pharmacies don't communicate directly, so they'll go through data warehouses or track and trace organizations to help facilitate the transfer of these non-real-time files. All right. So the DSCSA, man, I always have trouble saying that. So this is something that was passed in 2013, intended to stop diversion, primarily. All the deadlines for this are November 27th. And I always say to myself, what sadistic people would always make every single deadline Thanksgiving, right? This bill was passed on November 27th, 2013, and by law, the deadlines for it are on that same day and number of years afterwards. So every Thanksgiving, we have to look and see, what we have to do for this bill. You may have noticed these little squares on all the products. If you see all the vaccine news clips right now where they're showing little vials, they all have this data bar next to them. This data bar is not a QR code. I have the QR code up there. You can recognize the QR code because it has the red squares in the corners. A data bar has two solid lines, and in that data bar, there's the NDC number, a serial number for that bottle, the lot number and expiration date. So out of all the things that have come out of the DSCSA, even vet medications, having this on there is a huge plus for everybody, because I can track by serial number every single bottle that's shipped. So this is the third thing I want to talk about. Serialization is your friend. So we all deal with diversion, wondering where the pharmacy is getting their medications. Are they real? Are they given half away to their friends? By tracking serial numbers at the pharmacy level, you can help alleviate a lot of that. So if, for example, if you made it a requirement that serial numbers be reported with dispenses, if you got a serial number and the pharmacy then only shows dispenses for 10 of those pills, you may wonder, well, where is the other 90, right? So, and this is all just encoded in the barcode. So you don't have to have all these other fancy systems passing around this serialization data. It's right on every single vial on every single product that's out in the US right now. This was passed since 2018 or 2019, one of those years before the pandemic. But even repackaged medications from repackagers have this barcode on them, the data bar. So those are my three things to remember. There are encrypt data arrest starting tomorrow. Real-time transports only. There's no need to be just sending files around and waiting. We can do this, right? And then serialization is your friend, and it needs to be used to help reduce all the diversion that's going on. So pick your favorite. You don't have to remember all three, but tomorrow, all that stuff about the standards and all these different formats, you can forget all that. But please just one of these three things, take it and run with it. All right, so that's it for me. And Eric?
Yes.
Hello, so did I put you to sleep?
Oh, no.
Okay, good.
I learned some stuff today. Can you hear me okay?
Yeah, can you go ahead and introduce yourself?
Okay, great. Hello, everyone. My name is Eric Brantley, and I am an SOM engagement manager here with IQVIA. And I have about 22, 23 plus years in the industry dealing with, SOMs, DA compliance, and anti-diversion. And I'm going to spend some time today primarily focused on maybe 3 or 4 of the data points that that Theo mentioned: the A67, the A44, the A52, and possibly some dispensing data, because that's the data that's actually used in the industry as far as as it relates to SOMs or suspicious order monitoring. So the first is the A67 data. And what the A67 data is, that's data that the manufacturers can actually purchase from the wholesale distributors. And it shows that downstream activity. That's the thing now, as far as the manufacturers and having the ability to view that downstream activity. As far as SOMs, the manufacturers have a SOMs program. They have their own sales data that they can review for things straight from the CFR, orders of unusual size, frequency, or that deviate substantially from the normal order pattern. So they're monitoring their sales out to their customers. But as far as the A67 data, that shows that downstream activity from the wholesaler to the pharmacy or the hospital and so forth. So it shows that downstream activity, and the manufacturer can then see how their NDC numbers are moving. So that could be monitored on a regular basis. Could be monitored if you have an order that is flagged in your SOM system and kind of want to see what the downstream activity is for that wholesaler, for that product. That's what the A67 data is. And it can be reviewed, and you actually, the manufacturers can actually partner with their wholesale customers as far as, I reviewed this data and I noticed that, Eric's pharmacy may be ordering more than, other pharmacies, and, reach out to the wholesaler and get some due diligence information, because the wholesalers have all that due diligence, from the site visits to the questionnaires and, their sales data and so forth. And together that, that partnership can help strengthen this as far as, reviewing that. A44 or a chargeback data. Of course, chargeback data is a financial transaction that, if you sell a product at a contract price, then it's charged back. But as far as SOMs, that same data is housed in there. It shows that downstream activity. Don't really have to look at the price or the contract or the chargeback, just where did the product go? Who did the wholesaler sell it to, in what quantities and on what date, and so forth. And so that can be helped, again, when you're reviewing an order that has been flagged in your system, or you can just review that information on a regular basis, just trying to help identify the outliers, those registrants that, that may be ordering more than other ones, or may have some spikes, and you just want to get some additional information, some, due diligence information, just to make sure that there's no, potential, diversion going on. And then the H52 data, that's the data that actually lets the manufacturers know how much of their product is actually in the warehouse of their wholesalers. So that allows them to see how much of their, again, only their NDC numbers is on hand, and potentially what the average sales out have been. And again, that's just some information to help monitor, what the wholesaler is ordering versus what they're distributing, and how much they have on hand at any given time. Again, dealing with SOMs, that's very valuable information, because if you have an order that is flagged and you can see that their on-hand quantity is very low and so forth, it could be a restocking order, or vice versa. They have plenty of inventory on hand, and then you can, when you reach out to your customer, that's information that you have at your disposal. So those are the three data sets that, for instance, the manufacturers can use to actually view downstream activity, to actually help with, flagged orders again, and also just to do a periodic check of that data, just to help the wholesale customer identify, potentially, suspicious activity, or at least identify some pharmacies that have spiked and you want to get the information from. And it could just be that they're a very large pharmacy, compared to other pharmacies. But those are good tools to actually check that. The other thing from a wholesaler level, of course, the wholesalers have their sales data and have very robust SOM systems where they're monitoring that data. And also there's some ARCOS data. So the DEA some time ago did give access to some ARCOS data, on a limited basis, to where you can go in, you can enter the DEA registration number of a registrant and then the drug code in question, and you can see, I think over a 6-month time period, if there are other suppliers of that particular drug to that particular pharmacy, and if so, what quantities. It does not identify those other suppliers, but it's a way to see if there are if the pharmacy is receiving product from other suppliers, and that's information that you can have and to help with your SOMS program. The other thing, the wholesalers can get the pharmacy dispensing data, to where that's very helpful, because it sees what the pharmacy has dispensed, and what you sold that pharmacy of a particular drug or drug family or a strength, and that dispensing data actually sees what has been dispensed, and that's valuable information when you're determining if and how much you're going to sell of a certain product, controlled substance, to a pharmacy. And also, it actually helps gauge the size of the pharmacy. You can see, on average, how many scripts do they, fill a week or a month, and how does that compare to other pharmacies? Of course, there's no patient information, included in this data, but it could be prescriber information, and just help to see where the scripts are going, who's writing the scripts. And so that's all valuable information that's actually used in the industry for SOMs outside of the typical data, which is just the sales data that's actually coming into your SOM system, your sales down to your, to your customers. And those were the data sets that Theo mentioned, and those are the ones that I kind of wanted to cover at a high level. And at this point, just want to see if, Theo, if you had anything to add there, or if there are any questions, pertaining to the 867 or the chargeback or the 852 data that I might be able to answer.
Any question? Testing. Any questions from our audience?
So can I see a show of hands of how many people have unencrypted ASAP files sitting around on their computers right now, or seen them? And how many? Oh wow, nobody here. That's great. That's good. Okay. Fantastic. This is a good group.
Might want to ask how many don't have it.
I mean, well, okay. Well, then only 2 things to worry about.
Hi, thank you for your presentation. I have a quick question on the machine readable data for the NASCSA. Do you have any indications of how many products are labeled for machine readable from a percentage standpoint from the manufacturing side?
You mean the actual data bar that's on the products?
Yes.
100%. The FDA mandates it. Even my vet products have them on there. If you watched news clips recently of like when they're showing the vials for the vaccines, even they have it on there. So it's on 100% of the products. Now, one thing to be careful of, a lot of manufacturers are putting those barcodes right next to the other barcode on the product. And when you go to scan it, you typically get the easier one to scan. So you typically get the other one that doesn't have much data in it. So people become very crafty and you put your thumb over the barcode you don't want and you scan the little one to get all the data out of it. But it's 100% of the products right now. No compounds, but repackaged meds, everything you can see. Now, they don't put those on the vials that go to patients because the patients didn't know how to scan them. And about half of the barcode scanners out there, you can buy a $40 barcode scanner on Amazon with Wi-Fi, I mean wireless, and it'll scan the data bar format. The reason why QR codes not used is because typically there's no QR codes in medical practices because QR codes can have URLs in them. And by scanning it, you can take your phone to whatever website. And so that's how you view the menus at your favorite restaurant, right? Right now is this, you scan a barcode and you see the menu. Well, that's a security risk because I can put a very good barcode and make you scan it, take your phone wherever and put all kinds of viruses. And so in the medical community, there's no QR codes. They're all these data bars, which the data bars don't support URLs. They're just strictly bytes and bits in there.
Any other questions?
Hello. First off, thank you so much for the presentation. It was very informational. I was just curious, as someone who has a pharmacist background, this is one of the questions that I get the most. So when patients complain when they get the pharmacy because they claim that the doctor sent a prescription off to the pharmacy, like when they were at the office, but when they actually get to the pharmacy, we don't have anything. So when I see the presentation slide talking about there is a real-time transmission between the pharmacy, through the short, was it short?
SureScripts. Yep.
Yes. So I was just curious, what are some of the things that are causing the delay between the transmission between the doctor's office, SureScripts, and the SureScripts in the pharmacy?
Okay, and awesome, great question. So the normal transmission time of an e-prescription through the SureScripts network from their EMR to the pharmacy during the height of the day is on the order of 30 seconds. And we see that because we can send it here on this EMR, turn our chair and just wait for the pharmacy software and say that took 30 seconds. That's the word. Sometimes they get a little bogged down where it'll be a couple of minutes, but the majority of them, height of the day is 30 seconds, non-peak of the day, usually 5 seconds for that script to go. Now, the real-time interface is between the EMR and the SureScripts. SureScripts gets that data, and what they have to do is send it to the pharmacy. Most of the time that a script is missing is because the doctor picked the wrong location. The patient said, this is my favorite one, but they meant the other Walgreens, or the CVS, right? So they send it to the wrong place. So the NCPDP script standard supports what's called RX transfer, where two pharmacies can electronically transfer scripts between them. But the folks that control SureScripts don't like that. They don't want smaller pharmacies taking scripts away from the big box pharmacies. So even though it's in the standard, for years, they've said, nope, RX transfer not supported. You can only do new RX, refill request, and these messages. So pharmacists, when the script goes to the wrong place, you're forced to have a provider-to-provider communication to get that script over there. You have a phone call or something, or send another one, right? So this year, SureScripts finally caved in and started allowing the RX transfer. So we're certified right now for RX transfer. Problem is the other pharmacy has to be certified for it as well. And so we're just waiting for other pharmacies, the big box chain pharmacies, to get that service enabled for the RX transfer. And when that happens, going forward, at your pharmacy, you'll be able to just electronically transfer that script from the place it actually went to your pharmacy. Give it about 2 years, okay? So that's primarily the reason why scripts don't make it there, is because the prescribers sent it to the wrong place. And most of these prescribers are doing it in EMRs with some kind of display, and they type ahead, something like Walgreens, and a bunch of them show up. And and if the patient, they're communicating with the patient, trying to find the right one, right? And a lot of times it goes to the wrong place. So
Any other questions? Well, that looks like that'll end our questions. Eric, Theo, thank you very much for a very informative presentation.
Thank you. Thank you.
Okay, according to our agenda, you're now on your own for lunch, and we will resume at 2 p.m. with an update from the DEA. Thank you.